Imagine finding a world that defies every rule of physics we thought was set in stone. We assumed giant planets like Jupiter had to race around their stars at breakneck speeds, completing an orbit in mere months or even weeks. But the universe has a sense of humor about that. Today, we are diving deep into the discovery of TIC 659102228b, a massive superJupiter taking its time, circling its star every 180 days. This isn't just another planet in a catalog. It is a mystery that challenges our understanding of how these giants form and evolve. By the end of this video, you will see why finding a planet with an orbit so far from the Sun could change everything we know about the search for life elsewhere. Let's start by looking at what makes TIC 659102228b such a bizarre creature. To put its size in perspective, it is roughly 1.08 times the radius of Jupiter and weighs in at a staggering 4.78 times the mass of our solar system's king. It is a true superJupiter, but here is where things get interesting. It doesn't move fast. While many gas giants we study zip around their stars in under 100 days, this one takes 180.53 days to complete a single lap. That sounds like a long time for a planet, but in the context of stellar mechanics, it represents a distance that is significantly farther out than the typical hot Jupiters we used to believe were common. The planet orbits an F-type star, which is hotter and brighter than our Sun, yet this heavy world hangs out on the outer fringes of its system. This discovery forces us to reconsider the hot Jupiter paradigm. We thought these massive planets migrated inward from their birthplaces, but TIC 659102228b proves that a massive gas giant can survive and thrive much further away without being ejected or vaporized. It suggests that planetary migration might not be as universal a rule as we previously thought. Now that we understand the orbit, let's talk about what the planet is actually made of. The density of TIC 659102228b has sent shockwaves through the exoplanet community because it sits right in a sweet spot. With a calculated density of 4.69 grams per cubic centimeter, this superJupiter is surprisingly dense for its massive size. Compare that to Jupiter itself, which hovers around 1.33 g/cm. Why would a planet 4 times as heavy be almost 4 times denser? This tells us something profound about the internal structure of these worlds. It suggests that TIC 659102228b has a core significantly richer in heavier elements than typical gas giants. The star it orbits is metal-rich, meaning there was more heavy stuff available during its formation. This abundance likely allowed the planet to accrete a thick layer of iron and rock before it grew massive enough for gravity to stretch out the outer hydrogen layers. Unlike many superJupiters that are mostly floating blobs of gas, this one seems to be packed tighter. It challenges the idea that mass alone dictates density. Instead, the chemical environment of the star system plays a crucial role in determining how much stuff gets squeezed into the core versus how much remains as an atmosphere. The discovery of this planet was made possible by NASA's Transiting Exoplanet Survey Satellite, or TESS, and it highlights a strange new capability for space telescopes. For years, TESS has been the workhorse of exoplanet hunting, scanning sectors of the sky for planets that pass in front of their stars. However, TIC 659102228b is one of only 13 planets found by TESS with an orbital period greater than 100 days. In fact, it belongs to a very rare club. This makes it especially interesting because long-period planets are notoriously difficult to catch with transiting missions like TESS due to the sheer time required to wait for multiple orbits and filter out noise from other sources. Finding this planet suggests that our ability to detect these distant worlds is expanding faster than we anticipated. It also hints at a new era of observation, where we might be able to track planets over much longer timescales, potentially observing their evolution in real time rather than just getting a snapshot. The fact that it was identified so recently means the data sets are still being refined, and this planet could hold the key to unlocking how TESS will hunt for even larger populations of long-period worlds in the coming years. So, what does all this mean for the future of our exploration? The discovery of a superJupiter with an 18-day orbit opens up entirely new avenues for studying planetary formation and habitability zones. If we can detect these types of planets frequently, we might eventually find others in similar stable configurations that host rocky worlds closer to their stars. By understanding how dense gas giants like TIC 65910-228b interact with their parent star systems over centuries, we gain a better map of where to look for life. It also suggests that the universe is more diverse than our solar system models predicted. We are no longer limited by the idea that massive planets must be close to their stars to be stable or common. This realization allows astronomers to design new telescopes and strategies focused on wider sectors of space, potentially revealing thousands more worlds we thought were impossible to see. The search for Earth-like planets just got a whole lot bigger because we finally found a world willing to take its time around its star. So there you have it, the story of TIC 65910-228b, a super Jupiter that refuses to be hurried. From its massive size and high density to its slow, deliberate 180-day dance around an F-type star, this planet reminds us that the universe is full of surprises waiting for the right observer. We hope you enjoyed learning about how TESS helped bring this mystery to light. If you want more deep dives into the cosmos like this, be sure to hit that subscribe button and ring the bell so you never miss an update on our solar system neighbors. Drop a comment below telling us which exoplanet you think is the most fascinating to study right now. Thanks for watching, stay curious, and see you in the next one.